Chapter 3.3, Quick Review Problems 1 through 10. Section 3.3 in our book has to do with logarithmic functions. And since logarithms are really a different form of exponent, we're going to be looking at exercises having to do with exponents. In this case, we have exercise 1 through 6, evaluate the expression without using a calculator. And so this has to do with really the rule of negative exponents. And that rule specifically is that if you have a value x to the power of negative a, this can be rewritten as 1 over x to the power of a. And likewise, if you have 1 over x to the power of negative a, this expression can be rewritten as x to the power of positive a. So essentially, you're playing with the numerator and denominator. An exponent that is negative in the numerator becomes positive as that switches to the denominator. So here we have 5 to the power of negative 2. Well, using that kind of rule, that's going to be the same as 1 over 5 squared. And 1 over 5 squared is going to be 1/25th. And decimalized, if we take 1 divided by 25, we have 0.04. So this would be our correct answer for problem number 1. Next odd number problem, which is 3, we have 4 to the power of 0 over 5. Well, this is called the rule of 0 power. I think there's another name for it. That's what I call it sometimes. And basically, if you have x to the power of 0, that equals 1. Now, there is an exception. You can't have x be 0, but so what we have is 4 to the power of 0 over 5 equals, we have 4 to the power of 0 is 1. So we have 1/5 in fractional form, which decimalized is 0.2, which I write as 0.2. Okay, next odd number problem, which is 5. Here we have we have 8 to the power of 11 over 2 to the power of 28. The key thing is, if we can rewrite and make these bases the same, so I'm going to write that principle, make common bases. Well, we have in the denominator, we have a 2 as a base, but in the numerator, we have an 8. But can we rewrite one of these as a common base? Sure. 8 we can rewrite as 2 to the power of 3, right? 2 times 2 times 2 is 8. So let's rewrite our expression here. If we have 8 to the power of 11 over 2 to the power of 28, we can rewrite this as, we can replace 8 with 2 to the power of 3, and then we can put 11 on the outside. So all we've done is replace 8 in parentheses with 2 to the power of 3. And using the rule of power, this 2 to the power of 3 raised to the 11th is going to be 2 to the power of 3 times 11, which is 2 to the power of 33. And we bring down 2 to the power of 28. And then the rule of dividing exponents here is 2 to the power of 33 over 2 to the power of 28 is going to be 2 to the power of 33 minus 28. So we subtract as we divide. So 33 minus 28 is going to be 5, so we're going to have 2 to the 5th. And 2 to the 5th is 2 times 2, which is 4, and 4 times another 2, which is 8, 8 times another 2, which is 16, and 16 times another 2, which is 32. So our answer is going to be 32. Okay, finding the common base. That's the key skill being initiated here, or practiced. Okay, next exercise 7 through 10, rewrite as a base raised to a rational number exponent. Well, here, one of the skills we're looking at here is changing from a radical form of exponent to a rational. Okay, the radical is this kind of thing here. It could be this thing which is square root, this thing here which is cube root, and we change to rational. If we change that to rational, the square root is going to be to the 1/2 power, this cube root is going to be to the 1/3 power. So this square root we can rewrite as square root of 5. That's simply 5 to the power of 1/2. And that's going to be it. And then we get to problem 9, our last odd number problem. We have 1 over the square root of e. Well, what that's going to be is that's going to be 1 over e. Remember back here, problem 7, that's going to be the square root is to the 1/2 power. So that's going to be e to the 1/2. And then we go to the rule of negative exponents. If we have this positive exponent down here in the denominator, if we bring that up to the numerator, that's going to be e to the negative 1/2. And so that's going to be our answer for problem 9. Anyway, this is an exercise getting us ready for, again, section 3.3, which has to do with logarithmic functions and knowing these rational to rational exponential forms and simplifying exponents using basic rules of exponents, the key skill here. Good luck to you, and thanks for viewing.